Hello, good morning, everyone. Are you able to listen me? Hello, good morning, everyone. Are you able to listen me? So, in the last class, we have seen with respect to the fourth module, we have completed the fourth module. So, today we'll start the fifth module. I am audible to you? Hello, I am audible to you? Hello, am I audible to you? You can reply with a message. Hello, so I am sharing the screen. You tell me whether it is visible to you or not. Is the screen visible to you? So in the last class, we have seen with respect to the fourth module, fluid dynamics and discharge velocity and depth measurements, orifice and mouthpiece, notches and wear. So in today's class, we will see the fifth module, that is flow through pipes. So in this is very simple and easy module compared to your all the four modules, and it is very easy also. So in flow through pipes, what you have to study: introduction part, major and minor losses in a pipe flow, Darcy-Weisbach equation for head loss due to friction in a pipe, equation for head loss due to sudden expansion. In the next case, we have to see pipes in series, pipes in parallel, equivalent pipe, hydraulic gradient line, energy gradient line, and numerical problems. So here we have to see all these things. That is now, so today we will see the introduction part, flow through pipes. Okay. Why only 6 students are present for the first class? What was the attendance? Okay. So I am audible to you. Reply with a message at least, so that I will have the confidence that you are listening. Hello. I am audible to you. Okay, so today we will start the fifth module, that is flow through pipes. So in that, what we have to see, loss of energy in pipes. When a fluid is visible to you, so when a fluid is flowing through a pipe, fluid experience some resistance due to which some of the energy of the fluid is lost. The loss of energy is classified as, see here in this module we have to study the flow through pipes. When a water flows through a pipe, what are the factors, or what are the pressure forces it is experiencing, and what is the loss of energy, and what are the losses we have to study in this. Okay, now when a fluid is flowing through a pipe, the fluid experiences some resistance due to which some of the energy of the fluid is lost. The loss of energy is classified as energy losses, that is major losses and minor losses. So in the major losses, we have started with Darcy-Weisbach formula and Cheese's formula. Two formula are there. Whereas in case of minor losses, we have sudden expansion of pipe, sudden contraction of pipe, bends in pipe, pipe fittings, and obstruction in a pipe. We have to see all these things. So first we will see loss of head due to friction, as it is very important topic and also a guarantee question from this module. What you have to do in major losses, see here, what do you mean by first energy losses, you need to understand. Energy loss in the sense the amount of water which you are expecting from a pipe flow is reduced. Loss of energy is nothing but loss of discharge only. If suppose you are supplying water from a syntax tank, for so example, suppose it is of 1000 liter with the help of pipe flow. Is it possible that all the 1000 liters of water is discharged to you? No, there will be some losses in between. So in, you might have seen that water tanks we use during what you can say dry season, summer season, we will bought some water tanks from outside. So during the transportation phase, that is from the manufacturer to the place which where it is to be delivered, there is also in between losses. So these losses are classified as major losses. The name itself indicate major loss means more amount of water is lost, whereas next is minor losses, that is less amount of water or energy is lost. So in major losses we have to see two equation, that is first is Darcy-Weisbach formula, second is Chezy's formula. Similarly, in minor losses, we have sudden expansion of pipe, sudden contraction of pipe, bends in pipe, pipe fittings, and obstruction in a pipe. So this you have to remember. You may get a question in this way. Uh, State major loss and minor loss in a pipe flow. So you have to write this all these things. Now coming to the first, that is loss of energy or head due to friction. In this we have to see Darcy-Weisbach formula. So the loss of head or energy in pipes due to friction is called calculated using the formula or equation HF equal to 4FLV square divided by D into 2G, where HF is the loss of head due to friction. So I guess friction you might have studied in your engineering mechanics in the first year. So what is friction? Friction is nothing but a kind of force due to which there is skidding. If suppose you are traveling a bike, so you are traveling riding a bicycle, what you can say two wheeler or four wheeler. Suddenly, what will happen during overturning or whenever you are crossing a road, your tires and the tires of your vehicle will stick to the road surface. So why it is so? Due to friction only. So friction is a kind of opposing force or resistance force offered to a body. So due to friction also there may be some loss. That loss is given by the scientist Darcy-Weisbach. So based on his name only, Darcy-Weisbach formula is given, that is HF equal to 4FLV square divided by D into 2G. So this equation you have to derive. It is almost a certain question or a guaranteed question from this module. So now we will see the derivation for this module. So actually this is chapter 11 as per your textbook, but the derivation is given in chapter 10. See here they have mentioned in chapter 10 they have given the derivation. So we will move back and see the derivation in the chapter 10. So if you see chapter 10 is turbulent flow. In that first is Reynolds experiment which is not there in your syllabus. Next is this 10.3.1 expansion for loss of head due to friction. Don't worry, when I give you the notes I will give you in that way that you will not have to search in this way. Okay, so what is the expression for loss of head due to friction in pipes, we will say today. So it is a very important equation, you see it carefully. Expression for loss of head due to friction. Okay, so what we are assuming, first consider a uniform horizontal pipe. What we are assuming, a horizontal pipe is there. Consider a uniform horizontal pipe. This is your horizontal uniform pipe. Uniform pipe in the sense the diameter is same, having steady flow as shown in the figure. The type of flow is steady flow. We have seen different kinds of flow such as steady flow, unsteady flow, rotational flow, irrotational flow. Different kinds of flow we have seen. So this is also one kind of flow, that is steady and uniform flow as shown in the figure. After that what we are doing, let 1 1 and 2 2 in this pipe section, we are assuming 1 1 and 2 2 be the sections. Let 1 1 and 2 2 are the two sections of pipe. Let P1 equal to pressure intensity at section 1 1. What we are assuming, P1 as pressure intensity at section 1 1. V1 is velocity of flow at section 1 1. V1 is nothing but velocity of flow at section 1 1. Next, capital L is length of pipe between section 191 and 22. What we are assuming is a uniform horizontal pipe is there and the flow of water through this pipe is steady. The velocity is not changing. And 1 1 and 2 2 are the two sections. So the length between 1 1 and 2 2 is denoted by capital L. Length of pipe between section 1 1 and 2 2. Next, D is the diameter of this pipe. So this is nothing but diameter of pipe. Next, F dash frictional resistance per unit wetted area per unit velocity. F dash is nothing but frictional resistance per unit wetted area per unit velocity. F dash is your frictional resistance per unit wetted area per unit velocity. This you have to remember because we are dealing with loss of head due to friction. So you need to remember that F dash is nothing but frictional resistance per unit wetted area per unit velocity. Okay. After that, what you have to do? Let me take your attendance. Good to see the strength is improving. Okay. So F dash is frictional resistance per unit wetted area per unit velocity. HF. So what is HF? Loss of head due to friction. HF is nothing but loss of head due to friction. Next, P2 and V2. What is P2 and V2? Pressure intensity and velocity at section 2. P2 and V2 is nothing but pressure and intensity and velocity at section 2. Okay. I hope this is clear to you now. What it is, what we are assuming, once again I will repeat. Consider a uniform horizontal pipe having steady flow as shown in the figure. Let 1 1 and 2 2 be the two sections of the pipe. P1 is the pressure intensity of section 1 1. V1 is the velocity of flow at section 1 1. Next, length of pipe between section 1 1 and 2 2. And D is the diameter of pipe. F dash is frictional resistance per unit wetted area per unit velocity. HF is the loss of head due to friction. And P2 and V2 are the values of pressure intensity and velocity at section 2. Now, what we are doing, applying Bernoulli's equation between section 1 1 and 2 2. It is total head at 1 1 is equal to total head at 2 2 plus loss of head due to friction between 1 1 and 2 2. What we are saying is total head at 1 1, that is section 1 1, is equal to total head at section 2 2 plus loss of head due to friction between 1 1 and 2 2. That is summation of pressure head P1 by rho g plus V1 square by 2g velocity head plus datum head is equal to sum of pressure head, kinetic head and datum head at section 2 2 plus loss of head due to friction is given by HF. Now, as Z1 is equal to Z2, as the pipe is horizontal, what we are trying to see is Z1 is equal to Z2 as the pipe is horizontal. What we are trying to say, because the pipe is horizontal in the sense it is uniform, its diameter is also not changing, its velocity is also not changing, so automatically your diameters are same, d1 is equal to t2. So similarly z1 is also be equal to z2 and v1 is equal to v2 as the diameter of pipe is same at 1 1 and 2 2. Now your Bernoulli's equation is changed to p1 by rho g plus p2 by rho g p1 by rho g equal to P2 by rho g plus HF. This V1 square by 2g, this V2 square by 2g gets cancelled. This Z1 gets cancelled, this Z2 gets cancelled. So what will be your equation? P1 by rho g is equal to P2 by rho g plus HF, or HF is equal to P1 by rho g minus P2 by rho g. This is your equation 1. Loss of head due to friction HF is given by P1 by rho g minus P2 by rho g. Now if you see, but HF is the head loss due to friction. Hence intensity of pressure will be reduced in the direction of flow by frictional resistance. What is happening here is HF is the head loss due to friction and hence intensity will be reduced in the direction of flow of frictional resistance. See, as I told you, frictional force is a kind of opposing force or a kind of force which is offering resistance to the flow of water. आपका पानी जो स्मूथली फ्लो हो रहा था उसको ऑब्स्ट्रक्ट करने वाली फोर्स को हम बोल रहे हैं फ्रिक्शनल फोर्स. तो अब हम जो मालूम करें डेरिवेशन वो भी क्या है, लॉस ऑफ हेड ड्यू टू फ्रिक्शन इट इज. ओके, so HF is the head loss due to friction and hence intensity of pressure. If suppose the amount of water coming out from the outlet is reduced, why it is reducing? The intensity of pressure is reducing due to your frictional resistance. So now we need to calculate frictional resistance. So your frictional resistance is equal to frictional resistance per unit wetted area per unit velocity into wetted area into velocity square. Okay, so what we are trying to say is your HF is the head loss due to friction and hence intensity of pressure will be reduced in the direction of flow by frictional resistance. Now if frictional resistance, what is the formula to calculate frictional resistance? F1, frictional resistance per unit wetted area per unit velocity. So this is nothing but F dash, which we have to remember, into wetted area. So how to calculate wetted area? It is nothing but perimeter pi d into L. So F dash into pi dl into velocity square. So from here to here you have to remember in exam. How you will remember? Frictional resistance F1 is equal to product of F dash into pi dl into V square. What is F dash? Frictional resistance per unit wetted area per unit velocity. Next, wetted area how we will calculate? Pi into d into L. That is perimeter into length will give you area into velocity square. So your F1 will be equal to F dash into P into L into V square. This F1 we are trying to calculate. See here, your water is flowing in right hand side, this direction P1, P2. But this F1, what it is trying to do? It is trying to oppose the flow of water. So we need to calculate F1. So F1, that is frictional resistance, is equal to F dash into P into L into V square. Now we need to calculate the forces acting on the fluid between section 1 1 and 2 2. The forces acting on the fluid between section 1 1 and 2 2 are, what are the different kinds of forces acting on the fluid? First is pressure force at section 1. pressure force at section 1. So how you will calculate force? Pressure into area. P1 is the area into A, where A is the area of the pipe. Similarly, pressure force at section 2. So how you will calculate pressure force at section 2? P2 into A. Now frictional force F1 as shown in figure 10.3. This F1, it is in opposite direction. So what it will be equal to? P1 into A minus P2 into A, because P1 is moving in right direction, P2 is moving in left direction. So P1 into A minus P2 into A minus of F1. So your F1 is acting also in left direction. So minus F1 is equal to 0. So what will be your equation? P1 minus P2, A is common, equal to F1. Now from equation 2, we have calculated F1 as F dash into PLV square. So we will substitute the value of F1, that is P1 minus P2 is equal, P2 into A is equal to F1, which is equal to F dash into P into L into V square. Now P1 minus P2 is equal to F dash into P into L into V square divided by A. But from equation 1, P1 minus P2 equal to rho g h HF. From equation 1, P1 minus P2, rho g is LCM. So it becomes P1 minus P2 divided by rho g. So your P1 minus P2 will be equal to rho g into HF. P1 minus P2 into rho g HF. So now the equation will change to equating the value of P1 by P2 we get. In place of P1 by P2, what we can write? Rho g HF is equal to F dash into P into L into V square divided by A. Or your HF will be equal to F dash by rho g into P by A into L into V square. Now what we will do is, in equation 3, what we will do? We will calculate the value of P by A is equal to wetted perimeter by area. So your wetted perimeter is given by pi into d. Wetted area is pi d square by 4. Area normally is given by pi d square by 4. So this pi d will get cancelled. So in a place of P by A, what you can write? 4 by D. So your HF will be equal to F dash by rho G. In place of P by A, you will write 4 by D into L into V square equal to F dash by rho G into 4 FLV square by D. Now if you see here what we are doing, putting F dash by rho is equal to F by 2. What we are trying to do, in place of F dash by rho G, F dash by rho, sorry, what we are trying to substitute? F dash by rho is equal to F by 2. Why? Where F is known as coefficient of friction. See here, F is different, F dash is different, F1 is different. F, this small f is known as coefficient of friction, whereas your this F dash is your frictional resistance, whereas F1 is the frictional resistance force. Okay, now the equation 4 changes to HF equal to, what we are trying to do is, in place of F dash by rho we are substituting F by 2. So 4 FLV square divided by 2GD. So what your equation becomes? HF equal to 4 FLV square by D into 2G. So this equation 10.2 represents your Darcy-Weisbach equation, and it is commonly used for finding the loss of head due to friction in pipes. That is HF is equal to FLV square by D into 2G, where F is known as your friction factor. Okay, so this is your standard equation, HF equal to 4 FLV square by D into 2G. I hope it is clear to you. If you have understood, it's well and good. If you are facing any difficulty, or if you want me to repeat the problem, you tell me once again. You want me to repeat the problem? or shall we move on? Hmm? Waiting for your response. Reply with a message also. Do you want me to repeat the derivation or shall we move to the next part? Have you understood the derivation or not? Or you want me to repeat it once again? Yes, reply with a message at least. Derivation understood, sir. Okay. So shall we move to the next part? Because this is very important derivation and almost a certain question for 10 marks from this module. Okay, okay. So now we will go to next part. So Darcy-Weisbach formula we have derived. Now if you see here, this Darcy-Weisbach formula, that is HF equal to 4 FLV square by D into 2G, where HF is the loss of head due to friction, where F is coefficient of friction, which is a function of Reynolds number. That is, F is also equal to 16 times Re. While explaining the different types of flow, we have come across Reynolds number. So what is Reynolds number? It is a number which is used for differentiating laminar flow, turbulent flow, viscous flow and all. So what is the equation for what you can say Reynolds number? Your F is equal to 0.079 divided by Re raised to 1 by 4. For Re varying from 4000 to 10 raised to 6. So Re is your Reynolds number and L is your length of pipe, whereas a mean velocity of flow, D is the diameter of pipe. Now second is Chezy's equation. Second equation which you need to understand is Chezy's formula for loss of head due to friction in pipe. So you have to remember one more thing in exam, Chezy's formula derivation is not there for you. Only you have to remember the formula and solve certain problems on this. So what is the formula for Chezy's equation? Chezy is the name of the scientist. So Chezy, what he did was he gave a formula for velocity of flow, that is capital V is equal to C into under root Mi. This is Chezy's formula, where SC is known as Chezy's constant, and I is equal to this I is equal to HF divided by L, and HF is nothing but coefficient of friction. Just now we have come a loss of head due to friction from your this equation, the Darcy-Weisbach equation. From that you will get HF. HF by L if you do, you will get I value. Okay, next M. What is M here? M is nothing but area divided by perimeter, which comes out to be D by 4. So M is nothing but hydraulic mean depth. So how you will calculate hydraulic mean depth? Area divided by perimeter. Okay. So this you have to remember. Chezy's equation is for velocity of flow, that is given by V is equal to C into under root of M into I, where C is Chezy's constant, M is hydraulic mean depth, I is give loss of head per unit length of pipe. I is loss of head per unit length of pipe. HF by L is equal to I. Now we will solve certain problems on these two equations. Okay. So what is the first problem? Find the head loss due to friction in a pipe of diameter 300 mm and length 50 meter. What we are trying to say, we have to find the head loss due to friction in a pipe whose diameter is 300 mm and length is 50 meter, through which water is flowing at a velocity of 3 meter per second. Using first Darcy formula Next is C's formula, for which C is equal to 60. Take V for water as 0.01 stoke. So now what is V? Again, you need to understand. Stoke, what was the stoke? It is the CGS unit for kinematic viscosity, which you have come across in the first module. So because we are studying the fifth module, we need to have the knowledge of all the four modules. So what is given to you? First, diameter of pipe D is 300 mm. Fine. So you will convert this mm to meter. It comes out to be 0.3 meter. Next, length of pipe is 50 meter. This L is 50 meter. Next, velocity of flow is 3 meter per second. Next, Jesus constant C is 60. Kinematic viscosity V is given by 0.01 Stokes. So 0.01 centimeter square per second. So how you will convert Stoke to meter square per second? I told you, you should multiply by 10 raised to minus 4. So your kinematic viscosity is equal to 0.01 into 10 raised to 4 meter square per second. Now, Darcy's formula is given by the equation HF equal to 4FLV square divided by D into 2G. What is Darcy's formula? HF is equal to 4FLV square by D into 2G, where F is coefficient of friction is a function of Reynolds number Re, which is given by, see here, directly in some problems, directly the F value may be given. But in some cases, F value will not be given. So at that time, what you can do, you can use the formula which is connected with coefficient of friction F. That is, F is equal to 0.079 times divided by Reynolds number raised to 1 by 4. This formula also you can use to calculate the F value. And for finding that, you need Reynolds number. So what is the formula for Reynolds number? Velocity V into diameter D divided by kinematic viscosity. That is, velocity V is 3, diameter D is 0.3, kinematic viscosity is 0.01 into 10 raised to minus. So your Reynolds number comes out to be 9 into 10 raised to 5. Now, value of F, how you will calculate coefficient of friction F? It is given by F equal to 0.079 divided by Re raised to 1 by 4. 0.079 Re is nothing but 9 into 10 raised to 5 raised to 1 by 4. So it comes out to be 0.00256. That is your coefficient of friction value. Next, head loss HF is given by 4FLV square by D into 2. 4 F is 0.0256 into length is 50 meter. Next, V square is 3 square, velocity square, divided by D is 0.3, 2 into G is 9.8. So the head loss do using your Darcy's formula is given by 0.7828 meter. You have to remember here is the unit for head loss due to friction is meter. Okay. Now, using Cheese's formula, also you have to calculate the discharge. So what is Cheese's equation? V is equal to C under root Mi, where C is 60, where Cheese's constant is 60. Next, M is given by D by 4. Where you got this M is equal to D by 4. Here if you see, M is equal to area by perimeter. Area is pi D square by 4. Perimeter is pi into D. So this pi D gets cancelled. So D by 4 will be the value for M. M is equal to D by 4. You have to remember. M is equal to diameter divided by 4. Diameter is given to as 0.3 divided by 4. So it comes out to be 0.075 meter. So your velocity V is 3. Is constant is 6. Hydraulic mean depth M is given by 0.075 into I. So in order to calculate I, what we are doing is we are multiplying and dividing by squaring. We are squaring on both sides. So what will it will become? Your I comes out to be 0.0333. So once you have calculated I, what you can do, I is equal to HF by L. HF by length is 50. So equating the two values of I, we have HF by 50 is equal to 0.033. So your HF comes out to be 50 into 0.033. So it comes out to be 1.665 meter. This is the loss of head due to friction only. This is also loss of head due to friction. But if you calculate it from Darcy's formula, it is different. And if you calculate it from Cheese's formula, it is different. Why? Because Cheese's formula is entirely based on Cheese's constant. So surely it will have some other value. It is taken. So there is a confusion whether you have to use Darcy's equation or Cheese's equation for your analysis purpose. But the most acceptable formula is Darcy's formulas only. It is being accepted all over the world. So if you have any doubt regarding the problem, you ask me, or else we will move to the next part. Okay. Repeat, sir. Good. Good to see that you are focused. Okay. So once again, I am repeating it. You just listen. Find the head loss due to friction in a pipe of diameter 300 mm and length 50 meter. So diameter of the pipe is 300 mm, whereas length of pipe is 50 meter. Velocity of flow through which the water is flowing with the velocity of 3 meter per second. So velocity is also given as 3 meter per second. Using Darcy's formula, you have to calculate the head loss, and also using Cheese's formula. Taking C as 60. Cheese's constant is given as 60. And also dynamic kinematic viscosity value is given to as 0.01 Stoke. तो आपको मालूम क्या करना है, लॉस ऑफ हेड ड्यू टू फ्रिक्शन HF, इसकी मदद से विद द हेल्प ऑफ डायमीटर, लेंथ, Cheese's constant, velocity, okay, and Darcy's formula. So first what we will do, we will write down the things which are given to you. Diameter of pipe small d is 300 mm. So if you convert this mm to meter, it becomes 0.3 meter. Next, length of pipe L is 50 meter. Velocity of flow V is 3 meter per second. Cheese's constant C is 60. Kinematic viscosity is 0.01 Stoke. So how to convert Stoke to meter square per second? Multiply by 10 raised to minus 4. So 0.01 into 10 raised to minus 4 meter square per second. Now Darcy's formula is given by HF is equal to 4F LV square by D into 2G. This you have to remember. But if you see here, there is no value of F given to you. Length is there, velocity is there, diameter is there, G is there. But F is not known to you. So how you can calculate F? We have the equation for value of F. F is equal to 0.07 divided by Reynolds number Re raised to 1 by 4. So if you know the Reynolds number, you can easily calculate F. So for calculating Reynolds number, what is the formula? Velocity capital V into diameter divided by kinematic viscosity. So you have velocity as 3 meter per second, diameter as 0.3 meter, whereas kinematic viscosity is 0.01 into 10 raised to minus 4. So from this, you will get the Reynolds number as 9 into 10 raised to 5. Once you have calculated Reynolds number, Re is equal to 9 into 10 raised to 5. If you use this formula 0.079 divided by Reynolds number raised to 1 by 4, you will get the value of small f. So small f is equal to 0.00256. So now using your formula HF equal to 4, in place of f you can write this, in place of length 50 meter, V is 3 square divided by diameter is 0.3 into 2, G is 9.81. So the loss of head due to friction you are using your Darcy's formula is 0.7828 meter. This is the loss of head using your Darcy's formula. So first part is over. Now coming to the second formula or second part of the problem. So using Cheese's formula, what you can do? What is Cheese's formula? Velocity V is equal to Cheese's constant C into under root mi, where m is your hydraulic mean depth, I is your loss of head due to friction per unit length of pipe. C is given to as 60, Chezy's constant is given to as 60. So how to calculate M? Using the formula D by 4. This you have to remember. How we got this? M is equal to hydraulic mean depth, area divided by perimeter. Area is pi d square by 4, perimeter is pi d. So this pi d gets cancelled. So what will be your equation? D by 4. So M is equal to D by 4. So your diameter is 0.3 divided by 4. It comes out to be 0.075 meter. M is given by 0.075 meter. Now velocity V is 3, Chezy's constant C is 60 into M is given by 0.075. M is given by 0.075 into I is nothing but I only. So what you can do is, if you take this 3 divided by 60 to left hand side, if after that what you can do is into what we are doing, we are taking squaring on both sides. 3 by 60 square divided into this square 1 divided by 0.075 or square of 0.075. So it comes out to be 0.0333 if you do the calculation. Now I is equal to hf by L. This formula also you have to remember. From your Chezy's equation, what we come across, your I is equal to hf divided by length of pipe. So using this formula, what we can do, I is equal to hf by L. Hf by L is given to as 50. So you have two equations for I. One is hf by 50, another is 0.033. So what we are doing, equating the two values of I, we have hf by 50 is equal to 0.033. So your final answer will be hf equal to 50 into 0.033. So it comes out to be 1.665 meter. So the final answer for loss of head due to friction is 1.665 meter. This is your loss of head due to friction. I hope it is clear to you. So shall we move to the next problem, or still you have any doubt in this problem? Shall we move to the next problem? Okay. See here, next problem is find the diameter of pipe of length 2000 meter when the rate of flow of water through the pipe is 200 liters per second and the head loss due to friction is 4 meter. Take the value of C as 50 in Chezy's formula. So what we are trying to do, find the diameter of pipe, find the diameter of pipe of length 2000 meter. Length of pipe is given to as 2000 meter. When the rate of flow of water through the pipe is 200 liters per second, it comes out to be 0.2 meter cube per second. Divide by 1000 if you do, it comes out to be 0.2 meter cube per second. And the head loss due to friction is 4 meter. Loss of head due to friction is 4 meter. Take the value of C as 50. C we are taking as 50 in Chezy's formula. So length of pipe is 2000 meter. Discharge Q is 200 liters per second. It comes out to be 0.2 meter cube per second. Head loss due to friction HF is equal to 4 meter. Value of Chezy's constant is 50. So the diameter of flow we are denoting by D. So velocity of flow. Now what we are trying to use, discharge is equal to area into velocity. That formula we are using. So what will be your velocity equal to discharge by area. Discharge is denoted by capital Q. Area is pi d square by 4. So your Q is given to you as 0.2 divided by pi into d square by 4. So this 4 goes to the numerator. So your velocity will be equal to 0.2 into 4 divided by pi d square. So your hydraulic mean depth m is equal to d by 4. Now loss of head per unit length. What is the formula for loss of head per unit length? I is equal to hf by L. So your hf is given by 4 meter and length is 2000. So your loss of head per unit length comes out to be 0.002. I is given by loss of head per unit length is given by hf by L. hf is known to you or it is given to you in the problem itself. L is also given to you. So I comes out to be 0.002, no unit, because this is in meter, this is in meter, both will get cancelled. Chase's formula is given by the equation V is equal to C into under root Mi. So what you can do, you can substitute the value of V, M, I and C. So V velocity is 0.2 into 4 divided by pi d square is equal to C, Chase's constant is 50. Under root M is given by D by 4 into 0.02. So we are interested in calculating D. So what we are doing, under root d by 4 into 0.02, we are taking this to the right hand side. It will become 0.2 into 4 pi d square into 50 it will become. Or if you substitute this 0.2 into 4 divided by 50 into 3.142. Okay, so if you do it, it comes out to be 0.0509 divided by d square. What we are doing now, squaring on both sides, d by 4 into 0.02. So if you do the entire calculation, your diameter comes out to be 0.553 meter, or in other words, it comes out to be 553 mm. So what is the formula for diameter? 553 mm is your value for diameter of pipe. I clear to you. If you come to this part, you will calculate this because it is only mathematics. The thing is that you should understand how you are coming to this part. Is it clear to you, or you want me to repeat it once again? Repeat. Okay, fine. See, what we are interested in, we are interested in calculating the, one second, wait. Yes. Find the diameter of pipe. We need to calculate the diameter of pipe. Diameter कितना है pipe का? Whose length is 2000 meter. So length is given to you. When the rate of flow through the pipe is 200 liters per second. See, don't disturb the class. Disturb the entire class. Okay. So when the rate of flow of water through the pipe is 200 liters per second. 200 liters per second is nothing but discharge Q, and the head loss due to friction is 4 meter. HF is given by 4 meter. Take the value of C as 50, Ch is constant. Okay, so what we will do, we will note down the things which are given to you. Find the diameter of pipe of length 2000 meter. So length is given to you 2000 meter. Okay, fine. Next, discharge Q is given to you as 200 liters per second LPS. So how you will convert this to meter cube per second? Divide by 1000. So it comes out to be 0.2 meter cube per second. Next is head loss due to friction HF. It is also given to you in the problem itself. HF is equal to 4 meter. Next, value of Ch is constant, capital C is equal to 50. This much things are given to you. What you need to calculate? Diameter of pipe, small d. So from the things which are given to you, you have to be smarter enough to understand the problem. What is given to you? Discharge. So what is the formula for discharge? Area into velocity. So discharge is area into velocity. So what will be velocity equal to? Discharge by area. Discharge is denoted by capital Q Area of pipe is pi d square by 4 because most of the pipes will be circular in shape only. So Q is given to as 0.2 pi into d square by 4. This 4 goes to the numerator. It becomes 0.2 into 4 divided by pi d square. Next, hydraulic mean depth is given by m is equal to d by 4. This also you have to remember the formula for hydraulic mean depth m is d by 4. Similarly, loss of head per unit length, it is given by the formula I is equal to hf by L. Hf is there in your problem 4, length is also there 2000. So if you do the calculation, I comes out to be 0.02. Now, this formula is given by the equation capital V is equal to capital C into under root mi. Substituting the values of V, M and I and C, we get what we will get 0.2 into 4, the velocity 0.2 into 4 divided by pi d square is equal to capital C is given to in the problem itself 50. Hydraulic mean depth m is given by d by 4 into I is given by 0.002 or under root d by 4 into 0.02 equal to 0.2 into 4 pi d square. This 50 we are taking inside to the this side, 50 into this we are taking. So what it will become 0.2 into 4 divided by pi d square into 50. If you do the calculation of this part, that is what we are trying to do, under root of 0.002 divided by 4, or what you can say, see here, this is d by 4 and this is this much. This calculation you are doing 0.2 into 4 divided by 50 into this is what pi value is 3.142. If you do this entire calculation, this value comes out to be 0.00509. If you have calculators, you try to do it. I will also try to solve this in the calculator. 0.2, it is 0.2 into 4 divided by what is there, pi is 3.142, 3.142, next into 50. So it, yes, it is correct. It comes out to be 0.0509 divided by d square. This much you got. That is under root of d by 4 into 0.02 is equal to 0.00509 by d square. Now this is under root term. In order to cut this, what we are doing is squaring both sides. So what you will get if you square on the both sides, square and under root gets cancelled. So d by 4 into 0.002. This will be equal to 0.0509 square. D square will become d raised to 4. Okay. Now if you see, square of this is this much, equal to this much. Now d raised to 4 we are taking to the this side. So it becomes d raised to 5. So d raised to 5 is equal to 4 into 0.0002059 divided by 0.002. So it comes out to be 0.0518. So this is the value for diameter. The diameter of 5 comes out to be this much. If you take here, it is 0.0518 raised to 1 by 5. We are multiplying dividing by 1 raised to 5 because in order to cancel this term. So it becomes 0.553 meter, or if you convert this to mm, it comes out to be 553 mm. So this is your final answer. I hope it is clear to you. If not, you tell me, I will repeat it once again. Have you understood the problem or you want me to repeat?